Yeah. So, hi everyone again. Welcome to this webinar. This webinar is part of a series of webinars under the Healthcare Executive in Asia Leaders Program. It's organized by the NUS Sosui Hawk School of Public Health in partnership with the American Chambers of Commerce. And this webinar is also supported by Temasek Foundation. My name is Mary Chong. I'm an assistant prof with the NUS School of Public Health, and I'll be moderating the session today. We're very privileged today to have two distinguished speakers with us, Professor Colette Sko as well as Professor Lei. And together we'll be discussing the importance of diet in mitigating the risk of non-communicable diseases from a life course approach. And this means preventing risk factor exposure, now in this case diet, from early life as early as gestation, childhood, and continuing to adolescence and adulthood, so as to reduce disease risk in later life. So I'll first begin by providing us some background and some context, after which I'll introduce our two speakers and their topics. We'll end off this webinar with a Q&A session, during which I'd like to invite all of you participants to share with us some of your thoughts and experiences as we discuss the challenges faced by developing as well as developed countries in trying to improve population health through the diet. Okay, right, I'll begin first by giving some background. Okay, to begin now, we know that NCDs or non-communicable diseases, which include cardiovascular disease, cancer, diabetes, they're growing in prevalence. In fact, they're responsible for over 70% of global deaths each year. Now, of all these, around 85% occur in low and middle income countries, where people also bear the greater burden of undernutrition and infectious diseases. Now, in wealthier developed countries, NCDs disproportionately affect the vulnerable groups as well as the disadvantaged groups. And among the several lifestyle risk factors that contribute to NCDs, unhealthy diet is recognized as the biggest risk factor. So to be specific, according to the 2017 Global Burden of Disease data, malnutrition and poor diets are the two major risk factors for disease burden worldwide, as measured by DALYs, or Disability Adjusted Life Years. Now, of which maternal and child malnutrition forms a large proportion of malnutrition. And poor diet, as defined by a cluster of dietary risk, various risks here, is the second biggest contributor to NCD disease burden. Now, in the very same year, UNICEF also released a report recognizing that many countries, both developing and developed, are facing a triple burden of malnutrition. And here we're referring to undernutrition caused by deficient intake of energy and nutrients, leading to stunting and wasting. Malnutrition also refers to micronutrient deficiency, so deficiencies of vitamins and minerals, and it may be without overt signs of undernutrition or obesity. And finally, malnutrition also includes excessive and imbalanced intake, leading to overweight and obesity. However, the reality is that these problems are complex, and in fact, these three forms of malnutrition frequently coexist within the same country, same community, and even within the same individual. So for example, stunted children face a greater risk of becoming overweight as they grow up into adults. So all three forms of malnutrition are caused by unhealthy, poor quality diets, and thus are closely linked with NCDs. Now, the problem we face can be contributed in part to today's food systems, which have changed dramatically in the past 50 years. This focus on efficiency has led to an increase in availability of inexpensive, high-calorie foods, often from staple cereal crops, which in some ways has reduced hunger for many. However, this has often been at the expense of more diverse, nutrient-rich foods such as whole grains, fresh fruits and vegetables, legumes, and pulses. Now, we also see that unhealthy foods, high in salt, sugar, saturated fats, have become cheaper and more widely available. There's also a global demand for meat, dairy products, sugar-sweetened beverages, processed foods in more recent years. So indeed, there is a range of policies and various drivers that actually shape our current food systems. So for example, policies from agriculture, economic, trade, environment, they create incentives and disincentives for the production of particular types of foods. And different processes along our food chains, supply chains and food environment affect what foods reach which consumer and at what price. Many factors also influence consumers' dietary behaviors, whether it's personal, economic, or situational factors. Information about food, whether through education or marketing, also influences personal choices. And of course, on top of this, there are other major challenges facing the food system, for example, from globalization to urbanization, climate change, etc. In fact, in early 2019, there was a call towards transforming our current food system to try to improve the availability, the affordability of more nutritious and sustainable diets. However, COVID came along and threw a spanner into the works and have worsened the current situation. So what are we seeing now? So due to lockdowns and restrictions, okay, that has led to closure of whether formal or informal food vending, food services, resulting in food shortages, widespread job losses, as well as income shortages. This has led to supply chains, whether both domestic and international, being disrupted, leading to increased retail food price volatility in several developing economies in our region. So if you combine this with consumer concerns about food supply, this has led to behaviors like food hoarding, panic buying, plus being confined at home and in many cases unemployment. This means that many more people were not able to afford a high quality diet, therefore exacerbating malnutrition, the obesity problem, especially among women and young children, who are the most nutritionally vulnerable. Now, what then will be the long-term implications of maternal and child malnutrition, even decades beyond COVID? So we'll have Prof. Koletsko later on to share more about this with us. Now, besides mother and children, moving on from there, we also know that this COVID pandemic has highlighted the importance of everyone having a strong immune system. We learned that those who have existing chronic illness or weaker immunity, for example, elderly, are much more vulnerable to the effects of COVID. At the same time, we are aware that what we eat is intricately linked to our immune system. In fact, a healthy, balanced diet forms the foundation of our immune system. There's already existing evidence to suggest that avoiding excessive consumption of animal-based foods and replacing them with more plant-based foods can lower risk of chronic diseases as well as premature mortality. And in a very timely fashion, this came out early this year. This recent data is also pointing us towards the benefits of consuming whole and minimally processed foods for a healthier gut, which can subsequently lead to better health. So today we'll also be inviting Prof. Lay to share with us more on this very hot topic. So with this background, in this context, I'd like to introduce our very first speaker, Prof. Berthold Koletsko. Prof. Koletsko is Else Kroner Senior Professor of Pediatrics at the Ludwig Maximilian University of Munich. He is also the head of the Division Metabolic and Nutritional Medicine at the Children's Hospital. A well-known clinician researcher in the area of metabolic and nutritional modulators of child health and disease prevention, Prof. Koletsko is the author of over 1,000 journal articles, over 200 book chapters, and over 40 books or monographies. He is currently president of the Federation of International Societies of Pediatric Gastroenterology, Hepatology, and Nutrition. He is also president of the International Society for Research in Human Milk and Lactation. Prof. Koletsko is also scientific advisor on various committees, including the European Commission, WHO, FAO, and other national and international government bodies and organizations. So without further ado, I'd like to invite Prof. Koletsko to share with us his presentation. Okay, thank you very much.
Thank you very much. Good day, everybody. It's a great pleasure and a privilege to be part of this exciting session. And I thank you, Mary, very much indeed for the wonderful introduction, which makes my job much easier. So, as you said, I'm a pediatrician, so I would like to look in particular at the opportunities during early life for lowering the risk of obesity and associated NCDs that pose such a big burden on the health and well-being of people. As you mentioned, we've seen this enormous increase of NCD burden by about 1/3 in only 25 years. And Southeast Asia is no exception. Also in Southeast Asia, NCDs are the main causes of death. And we need to prevent. You already alluded to the opportunities we have, particularly with improving diet, among other lifestyle factors. And in my presentation, I just want to point out that we have particular opportunities in early life because there we have very large effect sizes if we improve diet and lifestyle. It is a problem for Southeast Asia. If you look at the increase of diabetes as one of the most common and most costly consequences of poor diet, then you see that Southeast Asia is among the world champions in the increase of diabetes. So we can prevent this. We can improve people's diet and thereby reduce risk. But as you all know, it's not an easy task to change lifestyle and dietary habits in adulthood when they are well established. And if you look at the data, if we intervene late when the obesity is already there or diabetes already is there, we only have a modest benefit. But if we intervene early in life, before and during pregnancy and childhood, and we can maintain the change in the risk trajectory, with the same effort, we will achieve a much greater benefit and therefore also an improved benefit to cost ratio. And this leads us to this exciting concept that if we improve nutrition during the first 1,000 days of life, we can really improve health, performance, and well-being, quality of life, lifelong. The first 1,000 days is an opportunity because this is a period of developmental plasticity when environmental cues, including diet and nutrition, induce lasting effects on our body structure, the body function, and thereby long-term health. We understand by these 1,000 days, the 270 days of the pregnancy and the first 2 years of life, amounting to a total of 1,000 days. And today we also add the preconception period, the pre-pregnancy period to this concept, because we know that this is really an opportunity for improving outcomes. I just want to share you a couple of examples that have brought us to think about this period as an opportunity. One element in the observations is the studies that have showed if women during pregnancy are exposed to hunger, then there is an increase in NCDs in the offspring later in life. One of these examples is the tragedy of the Dutch hunger winter at the end of World War II, when the west of the Netherlands was cut off from food supplies by the war lines. There was only 400 to 800 kilocalories per day of food supplies available. And of course, body weight of people went down. And what people have found is when women during pregnancy were exposed to this hunger in the first 2 trimesters of pregnancy, then their children in adulthood were much more likely to have obesity. In Germany and Austria, the hunger was not during the war, but after the war. And here, investigators have shown that if people were exposed to hunger at the beginning of life, during very early periods of development, then there was a marked increase in lifelong risk of diabetes, about 40% higher diabetes risk after periods of hunger. Today, we are more facing the opposite side of the risk coin, overweight and obesity increasing all over the world. And in this meta-analysis of 160,000 mothers and their children around the world, we have shown that the maternal body mass index predicts the offspring body mass index. The risk of the child to become obese is greater the heavier the mother is when she enters pregnancy. And interestingly enough, the effect sizes increase with the age of the child. The effect size of maternal overweight and obesity is relatively small in preschool age, and it increases in school age and in adolescence. The good news is we can do something about it. We can, of course, encourage women to try to approach a weight closer to normal weight when they plan a pregnancy. And also during pregnancy, it appears that if we improve diet and physical activity, we can decrease risk. For example, in this study from Australia, that was part of our European Research Consortia, counseling in pregnancy, focusing on less sugar and saturated fat intake and more physical activity, reduced birth weight above 4 kilograms by 1/5. And that is important because birth weight above 4 kilograms is known to double adult obesity. So the simple message is women before and during pregnancy shouldn't eat for two, but rather think for two. It's more about the quality of the diet, increasing micronutrient intake and not increasing energy, because the increasing energy needs in late pregnancy is no more than 10% compared to the requirement before pregnancy. We also have opportunities after birth, because we know that rapid weight gain in the first 2 years of life is a risk factor for later obesity. Children who have a higher weight gain, more than 2/3 of a standard deviation above the mean weight gain, have about twice the risk of obesity later in life. So if children grow fast now, have a weight gain fast now, they pay a price later. We should teach families, including grandparents, that the chubby baby, the happy Buddha, is not the ideal. It's associated with adverse effects. We need to encourage families to feed the baby such that they grow alongside the normal percentiles. Breastfeeding is one way to prevent rapid weight gain. Breastfed children have a lower average weight gain in the first year of life than children that are not breastfed. And that is associated with less obesity at school age. This is a study that we published more than 20 years ago. Was the first large study that showed that indeed breastfed children compared to non-breastfed children have a much lower risk of overweight and obesity at school age. And there is a direct relationship to the duration of breastfeeding. The longer the duration of breastfeeding, the lower the risk of obesity, which of course is compatible with the cause and effect relationship. Meta-analyses have confirmed this relationship. These are 4 large meta-analyses who all show that breastfeeding is associated with reduced obesity in later life up to adulthood between 12 and 22%. So the question then, of course, is why is it? Is it that there is just other socioeconomic factors, that the interaction of parents and baby is different in breastfeeding, or is it the composition of breast milk? We followed the early protein hypothesis, the concept that a high early protein intake in the first 2 years of life would induce higher weight gain and increased later obesity risk. Because we know that with conventional bottle milks, we provide much more protein, 1.6 to 1.8 times the amount of protein that breastfed babies get in the first months of life, whereas the energy intake is only modestly higher. And we thought this increase in protein might increase the concentrations of insulin-releasing amino acids in blood and tissue, and thereby the growth factors that act in early life, insulin and IGF-1, increase weight gain, increase body fat deposition, and thereby the risk of later obesity and other NCDs. We were lucky to be funded by the European Commission to perform a large randomized trial to test this hypothesis. We included almost 1,700 healthy infants at a mean age of 2 weeks. We had a reference group where parents decided to breastfeed exclusively for at least 3 months, or we had 2 randomized formula intervention for the first year of life with equal energy content, and then randomized double-blind to higher or lower protein intake for the duration of the first year of life. Feeding different amounts of protein the first year led to a lasting change in growth. Length growth was not affected, but weight gain was affected, and therefore the body mass index was markedly different. You see here the data at 2 years and at 6 years. It continues. We now have data at 11 years. We still see the impact at 11 years. Basically, the children who were fed a lower protein intake in infancy had a similar body mass index to those that were breastfed, whereas just the higher protein intake markedly increased the body mass index. And that translates into a very big preventive effect against obesity at early school age, with protein reduction in the first year of life. The risk of obesity at school age is reduced 2.6-fold. This is actually the biggest effect size of all tested obesity prevention intervention in children that we have today. So the conclusion is we have an opportunity through improved early feeding to prevent later obesity and associated NCDs. Breastfeeding protects, so this is another reason to proactively promote, protect, and support breastfeeding. For all infants, we should avoid a high protein supply. So for infants that are not fully breastfed, we would wish to choose today an infant formula with less protein, but of course that requires a high quality of the protein supply. Improved protein composition might provide further benefits, is another opportunity for further innovation and improvement. And importantly, for all infants, we should avoid animal milk, such as cow's milk, as a drink, if feasible and affordable, because we know animal milks have a much higher protein content. Cow's milk has 3 times as much protein as human milk or modern formula, and that is clearly associated with higher risk of NCDs and overweight. This is a study from the UK showing that if children had a high amount of cow's milk at 8 months of life, you were much more likely to be overweight at 10 years. So no cow's milk is a drink in the first year of life. This is just one example of a lot of evidence today how we can prevent NCD risk in early life. And therefore, the important question is now, how do we bring this across to the practice? How do we get families to adopt the information that is available today? And we have therefore developed an e-learning platform that targets healthcare and nutrition professionals across Southeast Asia to share this knowledge with modern, innovative, and interactive e-learning methodology. We had a European Union funded project together with universities in Thailand and Malaysia to build up this e-learning platform, which is really quite successful and very well used now. It provides e-learning, again, for healthcare and nutrition professionals on early nutrition and lifestyle across these first 1,000 days with a target to the needs in Southeast Asia. It's now available in English, Malay, and Thai, and it will be rolled out with another funding from the Ezekiel Fresenius Foundation into Indonesia and translated into Bahasa Indonesia. Have a look at it. It's really quite nice. It has an interactive learning design. It has video-based modules. And of course, people can earn CME points. We also have a YouTube channel, which has short video clips introducing the program. And it's very well liked. The results that we have are really encouraging. The people who do it love it. So go to inea-cia.eu and you'll find this program. Try it out. And if you like it, share it with your colleagues and friends. With this, I would like to thank you very much for your attention, and I look forward to comments and questions.
Thank you so much, Prof. Koletsko. That's a really enlightening and stimulating presentation, really opening our eyes to the importance of diet, not only during pregnancy, but also even in early childhood, not and also for current benefits, but also for longer term health benefits. Great, thank you. I'd like to invite the audience to pose their questions using the Q&A function that you see below. Okay, moving on, I'd like to introduce our next speaker. Okay. If I can get, okay. Our next speaker is Prof. Christophe Lay. He is senior scientist in the gut microbiome research at Danone Nutrition Research in Singapore. He's also an honorary adjunct associate professor in the Department of Pediatrics, Yong Loo Lin School of Medicine at NUS. Prof. Lay graduated with a PhD in gut microbiology from the Paris University, France, and his research interests revolve around the human gut microbiome and its contribution to maternal child health. So with that, again, we'd like to welcome Prof. Lay. Thank you very much.
Hello, everyone. Can you see my screen?
Not yet.
So let me try. Okay. Let me see. Can you see now?
Yes. Just need to switch it to presentation mode.
Yes.
Thank you.
So, slideshow. Can you see the screen?
Yeah, perfect.
All right. Hello, everyone. I'm Christophe. I'm a microbiome scientist. And today I'd like to share with you why we at Danone, we believe in microbiome science, how we are translating microbiome science into value proposition, nutritional innovation, product services, and why also we believe in collaborative research as a key asset to co-build the pyramid of scientific evidence to substantiate our innovation, but also to co-promote microbiome science. And to illustrate some of those points, I'd like to share with you one of my favorite scientific topic, which is early life microbiome. First, I'd like to tell you a story about this photography. Did you know that when a plant is about to release a seed, that plant, she will wrap, cocoon the seed with beneficial microbes in order to protect the young plant from environmental stressor, such as fungal infection or drought. Similarly, when a mom's-to-be is about to deliver a baby, she will also wrap or cocoon a baby in a blanket of beneficial microbes in order to sustain the healthy growth and development of a baby. Indeed, I like to raise your awareness that we as a human being, we have the responsibility to preserve this maternal microbial legacy that is transmitted from generation to generation, from grandmother to granddaughter, not only preserving this maternal microbial legacy, but also secure its healthy transmission to the next generation for the lifelong health. I'm going to tell you that the preservation of this maternal microbial legacy starts already during pregnancy, and several factors have been depicted to influence the preservation of this maternal microbial legacy. I'm going to tell you that pregnancy is not only associated with all those physiological and biological changes, but also a change of the gut microbiome. I'd like to share with you this study in which a group of scientists look at the gut microbiome over the course of pregnancy. In this study, they collected the stool samples of pregnant women during the first and the third trimester. They use a specific toolbox to analyze the microbes present in the stool of those pregnant women. And this is what observed as shown in this graph. So what you can see is that over the course of pregnancy, you see an increase of those guys in orange. This group of bacteria that we call the actinobacteria, they encompass a specific group of bacteria that we call the bifidobacterium. And the bifidobacterium could be referred as the best microbial friend of babies. Why? Because they are one of the few bacterial groups that have the ability to consume the human milk oligosaccharide or the breast milk sugar that are present in human milk. So this study suggests therefore that during pregnancy, there is what we call a programming or adaptation of the maternal gut microbiome. So mom is preparing her body to transfer the best microbial friend, the bifidobacterium, to her baby during birth. Therefore, what happens if this programming or adaptation of the maternal gut microbiome is compromised during pregnancy? Well, we have clues from birth cohort studies or epidemiological studies. There is now a growing body of evidence that indicate that prenatal exposure to antibiotics is a risk factor for allergy and obesity in the offspring, suggesting therefore that exposure to antibiotics during pregnancy may impact the maternal gut microbiome and indirectly impact the health of the fetus. Therefore, what can a mom do during pregnancy to build up a robust gut microbiome? Well, we are all fully aware that during pregnancy, a healthy diet rich in plant-based food is recommended. And I'd like to share with you this study where a group of scientists use a mice model, a model of pregnant mice model predisposed to develop asthma. So what they did in this study, they exposed those pregnant mice to a diet high in fiber, and they demonstrated that this diet high in fiber could modulate or shape the maternal gut microbiome of those pregnant mice. And this modulation was translated to the production of a specific microbial molecule or metabolite called acetate. And this group of scientists demonstrate that this specific microbial molecule or metabolite could actually prevent the baby mice, the offspring mice, to develop allergy, asthma later in life. If we now translate those animal studies, those findings into human context, there is now a growing body of evidence that indicate that a diet rich in plant-based food, such as the Mediterranean diet, can actually reduce your risk of allergy. So remember that we're always told that we are what we eat, but remember also that we also what our microbes do with what we eat. Birth. Birth is the second key event to preserve our maternal microbial legacy, and several factors have been depicted to influence the preservation, the transmission of this legacy to the next generation. And to illustrate this point, I'd like to share with you an ongoing collaboration with Professor Yuan Kun from the National University of Singapore. So in this study, we recruited 3 groups of mother-infant pair from the same public hospital. Why 3? Because they reflect the way we are born in a modern society. So there was one group of babies born naturally, one group of infants born by C-section, and one group of infants born naturally, but whose mom received intrapartum antibiotic prophylaxis during delivery because they were either diagnosed with Streptococcus or GBS infection during the 3rd trimester, or because they developed complications such as fever during delivery. In this study, we collected different types of biological samples during the 3rd trimester, but also during the 1st year of life. And the key objective of this study was to determine the impact of those clinical practices that surround birth on the early life on the baby microbiome. And I'd like to share with you here some first insight from this study. So this is a plot that reflects the composition of the baby microbiome when they were 1 month of age. So this plot is what we call an ordination plot. The red dot represents the baby born by C-section, the green dot, the baby born vaginally, naturally, and the blue dot represents the baby born vaginally, but whose mom received intrapartum antibiotic prophylaxis during delivery. So what you can see here is that in this plot, the green dots, so the baby born naturally, they tend to cluster on this side of the plot. So these suggests indicate that they share similar microbiome collection, so bacterial collection, and the microbiome was mainly driven by bifidobacterium. And I shared with you earlier that, remember, the bifidobacterium, they are the good guys that are being transmitted to the baby during birth, and those guys have the ability to consume the breast milk sugar that are present in breast milk. And if you look at those baby born by C-section or those baby born naturally, but whose mom received intrapartum antibiotic prophylaxis during delivery, the microbiome was actually depleted from bifidobacterium and enriched in opportunistic pathogens, such as, for instance, Klebsiella. So I shared with you just now that those babies at 1 month of age, they have what we call a compromised microbiome, depleted from bifidobacterium, Does this matter? Yes, it does matter. If you look now at the literature, there is now a growing body of evidence that indicate that a compromised microbiome in the first 3 months, in the first 100 days of life, is a risk factor for allergy and obesity. And it has been shown in several studies, for instance, that a depletion of bifidobacterium in early life is a risk factor for allergy. So once a baby is born, what are the key factors that contribute to shape its early life microbiome? Here again, there are several factors that have been depicted to influence the development of the baby microbiome in early life. We are all fully aware that human milk is the best source of nutrition for babies. Human milk is a source of hydration. It's also a nourishing biological fluid that contains specific micronutrients to sustain the healthy growth and development of babies. Human milk is also a living biological fluid that contains immune cells to support the programming of the immune system in early life, but also antibodies to support immunity in early life. Human milk also contains what I shared with you earlier, human milk oligosaccharide or breast milk sugar. Those are the third most abundant component in human milk, and they are known to contribute to shape the early life microbiome. And human milk is also a source of bacteria. Therefore, how does human milk therefore shape the baby, the early life microbiome? And I'd like to share with you this study in which they look at the impact of exclusive breastfeeding on the early life microbiome. So in this study, what they did, they collected the stool samples of babies exclusive breastfed during the first 4 months of life, but also they followed them during the first 2 years of life. And they used a specific toolbox to analyze the microbes present in the stool sample of those babies. And what you can see here that during the first 4 months of life, when those babies were exclusive breastfed, you can see that their microbiome was mainly enriched, populated by bifidobacterium. Remember the good friends that are transmitted from moms to babies, but not any type of bifidobacterium. They were colonized with what we call the human infant type bifidobacterium species. So remember, those bacteria are the ones that are being transferred or transmitted from generation to generation, from grandmother to mother to granddaughter. They have the ability to consume the breast milk sugar that are present in human milk. And by consuming those breast milk sugar, those bifidobacterium, they will be able to set up the right gut environment in the gut of the babies in order to sustain a healthy gut. And scientists believe also that bifidobacterium has a key role in programming the immunity of the baby in early life. So what happens once a baby is introduced to solid food or weaning food? Well, if you look at the literature, there is not much data on the impact of weaning food on the baby microbiome, but I'd like to share with you this graph that I extracted from a review paper where they summarize some of the key findings on the impact of weaning on the early life microbiome. So what you can see here is that during the first 4 to 6 months of life, when the baby is exclusive breastfed, you can see that the baby microbiome is mainly populated by bifidobacterium. Remember, those bacteria with the ability to consume the breast milk sugar or the human milk oligosaccharide. And then after, when the baby is introduced to weaning food, that occurs between 4 to 6 months of age, you can see that the microbiome starts to change. We do see here an increase of those guys in orange, the Lactose or the Minococci, the brown curve here. And those two groups of bacteria, for instance, they encompass specific group of bacteria that have the ability to consume, to digest the fibers, the phytonutrients present in plant-based food. So what I'm trying to tell you is that during the first year of life, there is what we call a kind of pattern of successive microbial colonization. First, establishment of the breast milk sugar consumer, followed by the establishment of the microbes with the ability to consume the fibers, the phytonutrients that are present in plant-based food. What happens if this pattern of successive microbial colonization is disrupted in early life? Well, we may have some clues from 7 independent birth cohorts across different geographical locations. So what you can see here is that in all those studies, they analyze the baby microbiome in the first year of life, and they observe that those babies that develop allergy in the first year of life, they all present a similar pattern of microbial colonization, which was characterized by a depletion of those microbes with the ability to digest, for instance, the fibers, or the polyphenols that are present in plant-based food. And why are those bacteria, those microbes so important? Because by digesting the fibers, the polyphenol that are present in plant-based food, those microbes that will derive some small molecule, microbial molecule or microbial metabolite, such as a molecule called butyrate. And butyrate is a molecule known to strengthen the gut barrier, the intestinal barrier, but also a source of, it's also a source of energy for the intestinal cells, and also butyrate has a key role in programming the immune system in early life. And if you translate that into into a clinical context, there is now a growing body of evidence that indicate that a healthy diet rich in plant-based food in the first year of life is negatively associated with allergy development. So remember, we are what we eat, but we also what our microbes do with what we eat. So those are my key summaries. So remember, we are always told that we should preserve the biodiversity that surrounds us, but we should also preserve our inner biodiversity. Thank you for your attention.
Thank you. Thank you so much, Prof. Lay. I knew the bugs and us were very, very important, but I didn't realize they were so powerful, right? Affecting from infants, and I'm sure to us as well. But thank you for the really fascinating talk, very, very timely topic. Okay, as we invite the audience to continue to put their questions for Prof. Lay, perhaps we'll start off the Q&A session by directing some of our queries, our burning questions to Prof. Koletzko. Well, thank you to the audience for the enthusiastic responses as well. I think there's been quite an interest in looking at actually animal protein. So I think the first question we can tackle here would be, have we been able to, and this is for Prof. Koletzko, have we been able to zoom in on the effect of animal protein in infants?
Yes, indeed. So several groups, including ours, have looked at dietary intakes in the first year of life and analyzed the effect of different types of protein. And if we look at the statistical evaluation, it is the animal protein, and particularly the dairy protein, that has the biggest effect on weight gain. And there may be two reasons for that. One is obviously a different protein composition of dairy versus plant proteins. But secondly, also, at least in Europe, infants have the highest intake of protein from dairy products, and the amount of protein from vegetables in the first year is pretty small, and also from other animal foods, meat and fish in complementary feeding is a relatively small amount of protein relative to dairy food. So we have to be a bit careful in interpreting this observation. Is it really the quality of the protein only, or is it a quantity effect?
Ah, okay. And I guess a follow-up question that another would be from Wendy here, Wendy Pang, saying about asking, what about cow's milk impact on obesity in children above 1 year of age? Yeah, so we talk a lot about the first year. How about beyond that?
Yeah, that's a very good question as well. A number of epidemiological studies have shown that the intake of protein also in the toddler age, but not the intake of fat or carbohydrate or total energy in observational studies, is associated with weight gain and later overweight and obesity. And therefore, we have actually started a randomized intervention trial in the toddler age. We have now completed recruitment of 1,600 children that were randomized at 1 year to do different dietary regimens, higher and lower in protein. And we hope that we will get results later this year on whether we can actually have a significant impact also after the first year of life.
Ah, okay, that's very exciting. We look forward to your results then. Great. Okay, just one more question here. There's by Mervyn Lee. Can I check if the statistics for nutrient intake and mother's weight during pregnancy are also translatable to the Asian population?
Yeah, very good question. Obviously, as humans, we are very similar around the world. If you look at the variation in genetics, we are all brothers and sisters. We have a very similar physiology around the world. And actually, the studies so far show this also for this point. Studies in Europe, for example, of course, have also included women with Asian ethnicity. And we don't see a difference. There's also studies in Asia. I just want to refer to the gastro study in Singapore, an excellent study that has looked at the effect of diet and lifestyle in pregnancy and body weight in pregnancy. And what I've seen is that gastro has found very similar effects in Singapore than studies in other parts of the world have found.
Yeah, great. Thank you. Thank you very much. Perhaps we switch over to Prof. Lay and ask him a few questions here. I think there's a very interesting question here on emerging research on the correlation on breastfeeding and gut microbiome composition. So the question here by attendee asks, how does dysbiosis in the gut microbiome in the first year of an infant's life contribute to an increased obesity risk? Again, I think we can open this question up to both Prof. Lay and Prof. Kolesko. Do you know of any current research related to this?
So thank you for the question. So let me answer this one. So basically, there are some ongoing research indicating that actually, yes, a compromised microbiome in early life, such as a depletion of bifidobacterium, could be a risk factor to develop obesity in life. But what is the mechanism behind it? There's not much insight at the moment, but there's actually little data on that, on the link between microbiome and risk of obesity in early life. There's more data on the link between compromised microbiome in early life and the risk of allergy. But I think the topic on the link between, yes, early life microbiome and obesity, this is something that need to be explored further.
I think there are some in animal models, right? But perhaps very little in human at this point in time. Okay. Then another interesting question here is on probiotics. So the question here is, for births with compromised gut microbiota, could probiotic supplementation help reverse such effect, such that the microbiome at the first year becomes similar to the babies born through vaginal delivery? Yeah, so share with us the power of probiotics.
Thank you for the question. So indeed, this is a topic that we are investigating here at Danone. So yes, there are some probiotics that we could use to basically correct, for instance, the microbiome of infant born by C-section. So I shared with you that earlier that baby who are born by C-section, they are born without the good guys, the microbes that have the ability to consume the breast milk sugar. So as long as we use a probiotic that have this ability to consume breast milk sugar, then yes, we are able to basically reset the gut environment of those born by baby born by C-section, and possibly reduce the disease risk later in life.
Ah, okay. Oh, that's good to know. That's very comforting to know actually. Just one more question here from Mei Chin. She asked about breastfed baby can also develop allergies. Do you think mom's diet contribute to the allergies? So the question is, breastfed babies also develop allergies. Is mom's diet contributing to the allergies? Yeah.
So maybe I can answer.
Yes.
So basically, we know that allergies are multifactorial diseases. They are different risk factors. So potentially, the diet of the mom, we know that the diet of the mom can influence the milk, the human milk composition. And so I think it's potentially yes, but it's a combination. At the end of the day, a predisposition. The predisposition of a baby to develop allergy in early life, it's actually derived from a combination of risk factors. It could be the microbiome, could be what kind of environment he lives. If he lives in the too clean environment, for instance. No, it's a combination of risk factors. The diet of the mom, I think, has a key role during pregnancy and also postnatally. Now, the diet of the mom, the diet of the babies. Actually, yes, it's a combination of risk factor.
Okay, thank you for that. Prof. Kolesko, a question here for premise. This is a question by Bao Xuan. For premise, is animal protein recommended? Do we have sufficient evidence to know that?
Both for premature and for term babies, animal protein is recommended because it is a higher quality protein. So we know if we feed a baby with a soy protein-based formula, we need a higher protein intake to meet the essential amino acid requirements. So yes, the best choice for feeding a baby is an animal protein. Human milk protein, of course, is the first choice, which is an animal protein. Or if human milk cannot be fed, then the second choice would be a cow's milk protein-based formula or another animal protein-based formula. Goat's milk formula is available in others. but that is certainly the better choice than a soy protein for a preterm or term baby.
Okay, great, thank you. Another question, if it's okay to take this, does parents' genes play a big part in obesity? So this
Yes, we all are the product of our genes, but oftentimes the effect of the genes is overestimated. There's one cite one study that is impressive in Europe, investigating 36,000 people and doing genome-wide analyses, and basically the totality of the 12 strongest obesity predicting genes, including FTO, explained less than 1% of the variation of the body mass index. So genotype alone does not explain the obesity epidemic, and of course it doesn't explain the increase of obesity. What is more interesting, of course, is the interaction of genetic variation with diet and lifestyle. We have many indications that obesogenic diets do not have the same effect in each and every individual, but we have some indications that, for example, variation in fat oxidation between people genetically based have an impact on the obesity risk on high fat diets. So that's the more interesting question for me as to whether is it diet or genes. That's the wrong question in my view. It's both, and the diet is the thing that we can change.
Yeah, no, that's good to know. I think we kind of know from before that diet do play a part, but I think increasingly we know that environment actually plays quite a big role here as well. Yeah. Back to Christoph, Prof. Lee, you've shared about the value of gut health for infants and mothers. What about adults and even elderly? Are you aware of studies to show that optimizing gut health can also improve immunity in adults and elderly?
So yes, there are actually a growing body of evidence that indicate that when you age, your microbiome is changing. But what all those studies indicate, for instance, if you look at all those studies, they look at the microbiome of obese adult or patient with diabetes or aging people. So when they compare those populations to the healthy groups, the consistent pattern is that those patients, those subjects that stay healthy, their microbiome is actually enriched with those microbes that have the ability to consume fibers, polyphenol that are present in plant-based food. So this is quite a consistent biomarkers that we can see in this specific group of healthy subjects. And there was actually a recent study also indicating that actually by analyzing your poop sample, you can actually predict if you have a healthy diet. Actually, if you know, you may ask someone, oh, are you eating healthy? Yes or no? So if this guy lied to you, but you can actually, by analyzing his poop sample, you can actually determine whether or not he's lying to you, because you can detect basically in this stool sample whether or not he does have those good microbes that can metabolize those healthy nutrients that are present in plant-based food.
Okay, wow, that's going to change our nutrition consultation in the future. Instead of just talking to patients, I'll be asking for patients' poop, just for real evidence rather than just relying on what they tell us. Oh, wow. Great. Thank you for the insights. I've got a couple of broad questions for you both. I talked about just now trying to transform the food system. I know all that will take time. We also require multi-sectoral, whole-of-government approaches. And while we wait for all this to happen, do you think we individuals can play a part in trying to mitigate this problem of malnutrition in mothers and children? And when we talk about malnutrition, it means undernutrition, even as what Prof. Kolecko mentioned just now, this whole increasing prevalence of obesity. Yeah, you're just like, if you'd like to share your thoughts on this, whether
Absolutely,
we individuals.
Yes. Yes, of course, families have a very important role to play. Well-informed families can choose diets and lifestyles for themselves and have a huge impact of their children. Children follow the model of parents. But I think it's not enough to just give all the responsibility to individual families, but we also need to improve societal standards, particularly in the families that are less privileged. They need help, they need support. So what is offered in terms of the food system, the pricing policy, all of this has shown to have a marked impact on food choices of people. So I think it's a combination of an individual responsibility and an opportunity for societal standards to improve the lifestyle and health of people. And it's worth investing here because the return of investment is huge. If you think about the cost of NCDs, of the obesity epidemic, of type 2 diabetes, it's huge. It's huge for society. No society on earth can afford to close its eyes of it. So if societies invest in improving standards by simple things like improving standards of school meals, by limiting advertising to children, by limiting sharing of sugar drinks, and all these little things, it can have a huge benefit to cost.
So you're saying that individuals, not just in the family environment, but also stretching out to the school environment, if a workplace environment as well. Yeah, and then overall
Sure.
policies. Christoph, anything to contribute to this part here?
Yes, so I think as a parent, as a dad, I think it's key for parents to empower our kids to eat healthy. And also, I think what Professor Bert just mentioned, I think school maybe also has a key role to educate about nutrition to young kids. And I thought that this is already happening. For instance, my kids has been recently empowered with the 5-2-1-0 rules, like 5 fruit and vegetable per day, not much than 2 hours screen per day, 1 hour physical activity, and 0 sugar consumption per day. So I see that happening already, and I think kids could also empower our parents to eat healthier. I think that was thinking. And I think also my other point would be the medical community. I think there should be, if I sorry to say, but I think that should be more empowered with nutrition, because sometimes I don't feel that they make the connection with health and nutrition. To give you an example, one of my relatives, she was hospitalized several times, and my brother sent me the picture of the lunch of my niece. I was not very convinced. It looks really like a very sad plate, and there was no microbiome friendly, food ingredient except maybe the yogurt pot.
Yeah, I think you brought a very important point, because it's also about, sometimes we think that people know that, it's common knowledge that people know about the importance of diet in infants and mothers, but then that may not necessarily be so, or we think we know. Yeah. So that, I think, brings me to like the question about the challenges, right? What do you think are some of the challenges that we face as individuals, whether in developing or developed countries? Some of the cultural challenges. So for example, I know in Asian countries, at least traditionally, a lot of the mothers would basically, they think more for their husband and their kids first. So anything that is nutritious or good on the table, that's always offered first to the family, and then they will basically eat the leftovers or the scraps, So, but I think at the it's the thinking that they don't realize that their health also needs to be taken care of, also because, especially if they're expecting the next child or subsequent children. So thought, any views on this, or from your experience with working with developed countries, what are some of the challenges or trying to get over this knowledge barrier, or trying to really educate? I mean, Prof. Kolesko, you're part of this early life program, right? About using the web to actually educate, whether it's health professionals or even these lay people, and trying to bring up this aspect of health literacy for the importance of maternal child health. Yeah, any thoughts on this?
Yeah, I couldn't agree more with you. This is really an important priority. With respect to the observation that parents, and particularly mothers, prioritize the needs of children, it's actually, in a way, it's a protective instinct that we all have. Our children are something that we really prioritize, that we care for, that we think is the most important thing in our life. And in a way, it's great, because that motivates then parents to change their own lifestyle to the benefit of their children. And it's a greater motivation than just to change lifestyle for your own personal benefit. So in a way, it's a golden opportunity to address people that plan a pregnancy, that are pregnant, or that have young children, because then this is a window where people are willing to reflect and change. And how can we do this? As you say, we need to try to get the word out to families directly, and we need to get the word out to those people who multiply the information, who are credible multipliers. And this is what we have tried with the Early Nutrition E-Academy Southeast Asia, addressing doctors and other healthcare professionals, nurses, midwives, who talk to families every day, as well as dietitians and nutritionists. And I think this is a good opportunity. Many of them, as Christoph has said, in the medical field are not well enough informed about current knowledge in nutrition. And so we need to close that gap and get them up to speed with what the current evidence is. And if we do so, then they can, in every encounter they have with a patient, use that opportunity to spread simple messages. We have one study in Europe, for example, where doctors were randomized after the birth of the newborn child to talk to parents and just say one single sentence on optimal introduction of complementary foods. One sentence more, and half of the parents were confronted with the sentence. When the newborn baby was examined, the others were not. And 6 months later, it resulted in a significant change in the practice of complementary feeding. So that shows the power of simple, clear messages that healthcare professionals can give to people.
Oh, that's amazing that just at one sentence. So not overwhelming people with, like floods and floods of information, but actually just that one, two, and also to the correct people, isn't it? So we talk a lot about mothers and infants, but actually fathers also play an important role, whether it's in role modeling and also in this case, I think even epigenetically, they also see the influence of fathers' epigenes also on children. Yeah, so
that's,
actually the entire
that's absolutely
family.
true, and very exciting to see that the father's body mass index, for example, influences in neonatal epigenetic code. That's amazing. And I just remember one other finding that surprised us. We did a study on what predicts breastfeeding success in families in Germany. Mm-hmm. And the biggest risk factor for not breastfeeding or for short breastfeeding was actually non-supportive attitudes of the partner. So the father has an important role. In the previous times, you only talked to women before pregnancy about breastfeeding. Yeah. Now we've changed our practice and talk to both partners and try to inform them about the importance of breastfeeding, because we realize the mother doesn't take a decision in isolation. She talks to her partner.
Yes. Like the whole family needs to come in. Fathers are just equally important as moms. Yeah.
Well, it's reassuring for men that we still have a role.
Oh my gosh, you all have a key role, everybody. Despite all that focus on Women's International Day, I think men, we also should have an International Men Day. Yeah.
I think we should put the pressure on that. I mean, that's to be that they have also a key role in the health of their future babies. No, it's that diet also contribute to that.
Yes.
So it's not only the moms to be, it's also the dad to be.
Correct. And a lot of decision making sometimes at home was also very dependent on father's preference of food as well, right? Yeah, cool. I'd like to just take this chance to also open up the discussion also to our audience. Anybody who would like to share with us, anybody from the Asian our Asian region, Asian countries, who would like to share with us their experiences where you yourself faced in your workplace or in family, in terms of the challenges you think, in terms of trying to promote population health, promote healthy eating, whether it's in your for mother and child, or even trying to convince dads to follow that. Would anybody like to share or give their thoughts? I'll just wait 5 seconds. If not, then I'll maybe just ask, I'll just run off the session with another 1 or 2 questions to the 2 profs before we end the webinar. Okay, great. No worries. What we'll do then is, I think there's another interesting question. We'll just end off with 2 more questions, okay? To Prof. Lay, will obesity during pregnancy affect the baby's gut microbiome? That's the question here. And would using probiotics or prebiotic rich diet mitigate this adverse effect?
So that's a very interesting question. So actually there's one hypothesis that if the mom is obese during pregnancy, the hypothesis that her during birth she will transmit her obesogenic microbiome to her baby, and this obesogenic microbiome could actually contribute to predispose a baby to become obese later in life. But this is just one hypothesis, and I think this is something that need to be investigated, in the future. Perhaps some research group are already investigating this topic, but at the moment, yeah, just hypothesis, I would say.
Cool, thank you. And to Prof. Glasgow, one question here. Is the maternal diet and the diet of the infant within the first 2 years of life a main contributor to lactose intolerance? So this is a question related to lactose intolerance, whether is it the mother's diet or the infant's diet that's the problem.
Thank you for that question. The answer is easy. The answer is no, because lactose intolerance is really genetically based. We can now easily test with a simple genetic test who has the disposition for lactose intolerance or not. And the maternal diet or the infant diet does not change the risk. Of course, how much lactose you eat affects how much symptoms you would get if you have the respective genotype. But the good news is infants and young children are not lactose intolerant because it's a developmental process. The lactose intolerance is our normal genotype. Lactose tolerance is the deviation, the mutation that happened in human evolution in Europe. So infants were always dependent on milk, on human milk intake, and therefore evolution ensured that there is no lactose intolerance, with very few exception of a rare genotype in Finland. In infancy and young children, it develops at school age. So no worries about what the mothers eat on the baby's lactose tolerance.
Okay, phew, that's good news. Great. Okay, thank you very much. We have come to the end of this this webinar. I'd like to thank our two speakers, Prof. Kolesko, Prof. Lei, once again for answering our questions and also for great presentations. Also, let's say a big thank you to the audience for attending this webinar. It was a pleasure to have you with us, and we hope that you have learned as much as myself and also enjoyed this webinar. Have a very good evening, and we'll see you at the next webinar organized by the Healthcare Executive for Asia Leaders. Okay, thank you, everybody.